Welcome back. Let us discuss a few properties of laser. It has five basic properties, five most important properties. Otherwise, number one is directionality, number two is intensity, third one is monochromaticity, brightness, and coherence. With reference to directionality, lasers, as we said, are highly directional in nature. When a beam of when a laser beam of wavelength lambda emits from a source or emits from a lasing device having an aperture of diameter d is the diameter of the aperture through which the laser beam will be emitted from the lasing device. Let this beam propagate as a parallel beam for a certain distance known as Rayleigh range. Rayleigh range is the distance through which the laser beam propagates as a parallel beam without any diversion. Without any diversion. And the distance across which it propagates as a parallel beam is called Rayleigh range. And the Rayleigh range is given by the expression d square by lambda. D square by lambda is the Rayleigh range, where d is the diameter of the aperture and lambda is the wavelength of radiation or wavelength of laser beam. And after this distance, called the Rayleigh range, it began to spread linearly with the distance, and that spreading is because of diffraction. And the expression for angular spread is given by the expression for angular spreading of this laser beam after traveling or after this Rayleigh range is given by the expression delta theta equals lambda by d. Delta theta equals lambda by d. As you know, lambda is the wavelength of laser beam, d is the diameter of the aperture. For a typical laser, this angular spread will be of the order of 0.01 milliradian. In the sense, the beam spreads less than 0.01 millimeter for every 1 meter distance traveled after the Rayleigh range. After the Rayleigh range, after the Rayleigh range, it spreads about 0.01 millimeter for every 1 meter distance traveled. Hence, it is highly directional because the spreading is negligibly small. Negligibly small. That too after Rayleigh range. And the second property is the intensity. As we already said, laser is very highly intense. It is highly directional. Laser light consists of large number of photons having same phase. Let us consider the amplitude of each photon as equal to small a. Let the amplitude of each photon is taken as equal to small a. If there are n number of photons, if there are n number of photons, then the amplitude of the laser beam will be equal to Na. Will be equal to Na, where n is number of photons in the laser beam and A represents the amplitude of each photon. Therefore, Na represents the amplitude of laser beam or the net amplitude of all the photons in the laser beam. Since the intensity is directly proportional to square of the amplitude, therefore I will be proportional to Na whole square or n square a square. Since n itself is a very large number, its square will be further larger, hence intensity of the laser beam is very high. It will be of the order of 10 power plus 17 watt per meter square. Intensity of laser will be of this order. Now, the third property is monochromaticity. We know that laser is highly monochromatic in nature in the sense it will have single wavelength. It will have only one wavelength. There is no from to values. It will have single wavelength, and therefore we say that laser is highly monochromatic in nature. And the fourth one is brightness. Lasers are very bright in nature. They are highly brighter when compared to other sources. The brightness can be defined as the power emitted per unit area per unit solid angle. The brightness can be defined as the power emitted per unit area per unit solid angle. And the last one is coherence. Waves in laser beam have a definite phase relationship. Waves in laser beam will have a definite phase relationship, and all the waves are in phase with one another. All the waves will be in phase with one another. Two separate beams, two separate beams traveling certain distance can again be superposed to produce a permanent interference pattern, such is the coherence of laser beam. Hence, laser is said to be highly coherent because even two separate beams after traveling long distances can again superpose and will produce an interference pattern. And the photons of laser beam will have same energy, same direction of propagations, and same direction of polarization. Hence, laser will be highly coherent. So these are the main properties of laser.